Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about all questions all the time on this very special episode. And of course, we'll be taking listener and viewer questions because that is going to be 100% of the show today. And that is 100% of our entire universe. Yes, our universe is made of questions. No, that doesn't make any sense, but it doesn't matter. We record the show every Thursday at 4 p.m. Eastern, and you can leave a voicemail by going to spaceradioshow.com and leave a voicemail question anytime. And in today's Blue Shift, I will be, answering some more questions. It's a very special edition of Space Radio. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State. And for the next half hour, your agent to the stars. I got an exciting show for you today on Space Radio where we talk about everything, just all the things. This show lives on viewer questions. We record every Thursday at 4 p.m. Eastern. I am not in Studio A of WCBE Radio Columbus. I am in the lovely city of Denver, Colorado. I literally just flew in an hour ago and I set up. I'm ready to go. I'm ready to record, doing this show from Denver. You know why? Because I care about you. That's why. And I also really like doing this show. And so here I am and here you are bombarding me with questions because I didn't do any prep work at all for this entire show. So it's all questions all the time. I am taking questions from the voicemails and also from the space cadets who are tuning in live to YouTube and Twitch. And you can join them on spaceradioshow.com. Check out the links to the YouTube and Twitch live streams, and you can be a space cadet. Seriously, folks, I've only prepped absolutely 0 minutes of show material tops, so get those calls in. How long would it take to walk across the universe? I love this. Things with ridiculous half-life. Oh yeah, there was that double beta decay thing, pure ostension. That was a good one. Who asked the first question here? Matthew DeFleury, what are your thoughts on Tabby star? All right, we can do Tabby star. I'll do a segment on that. Here we go. And to start us off today in this all exciting episode of Space Radio. I mean, every episode is exciting, don't get me wrong, but this one is especially exciting because it's all questions all the time. Starting us off, we've got Space Cadet Matthew DeFleury over on YouTube asking, what are my thoughts on Tabby's star, aka Boyajian's star? This was a very interesting and curious object discovered, let me see, it was about 2 years ago, and it had a very, very peculiar light pattern where the light from the star was bright for a while doing its normal thing, and then it would dip suddenly like a lot by like 30%, which doesn't sound like a lot, but if you're a star and you dim by 30%, that's a lot. And then that would last for like a day or a week, or I forget the exact number, some amount of time. And then it'd pop back up. And then some random amount of time later, like a few days later, it'd do another massive dip of like 10, 20, 30%. And this is a very, very strange thing for a star to do. Up until that time, we hadn't found any stars that did exactly this. So it's very, very curious, like what's going on with the light from this star? Why is it dimming? Why is it returning normal? Why is it dimming so deeply? Why is it dimming so irregularly? So there was a paper written by Tabitha Boyajian. They wrote out like, okay, here's our observations, here's how we collected the data, et cetera, typical fun, fascinating to read scientific paper. And at the end of it, she said, or all the authors said, we don't really know what it is. Here are some possible explanations. One of the explanations that was boosted by a companion paper that was written by some colleagues and published, nearly the same time, was that maybe there's like aliens built a bunch of stuff around the star, and the stuff is orbiting around the star, and it's big enough, it's a mega structure, it's gigantic, and every once in a while blocks the light from the star, and that's what's causing the dimming. So like you imagine like there's a bunch of like hexagons and panels and walls orbiting this star, and every once in a while one of these massive walls just careens around and blocks our light, the light from the star. Of course, as you can imagine, instant worldwide fascination. Like, wow, have we found evidence for aliens? The answer is no. Everyone in the astronomical community said the answer's no. What are you talking about? The immediate reaction within the astronomical community was it's dust. Because dust like is capable of explaining almost every astronomical observation in all of history. No one really took this like alien megastructure hypothesis seriously, but still it caught fire around the world. The researchers are, of course, getting quoted in newspapers and giving talks and like saying, of course we don't know, but it could be an alien megastructure. And me, you know how I feel about unfounded hypotheses, especially when it comes to extreme hypotheses like aliens who are capable of doing anything they want. So no matter the light pattern you found from this star, there will be an alien that could be responsible. And that's not really good enough. And I'm actually going to switch to the next segment now. And I'm going to smoothly transition. I'm going to finish this. Don't worry, I'm going to finish this. And then I'm going to go to a voicemail. That is my plan. That is a very good plan. That's the plan we're going to do. Reset. Okay, sorry, I got a timer going on here. Okay, so we're back in the show. We're doing another segment. I'm answering a question from the Space Cadets about Tabby star, aka Boyajian star. And so everyone in the astronomical community was, when they saw these like weird light curves, the dimming from the star, they're like, yeah, it's dust. What's the big deal? That's not how the world saw it, of course, because, it's dust is not so exciting a headline, whereas it could be aliens is a very exciting headline. So, of course, they did a bunch of follow-up observations because, hey, it might be aliens. And what they found with the dimming of the light from the star is that different frequencies of light dimmed differently. So, like, bluish light was dimming in one way and reddish light was dimming in another way. It's dust. Because if you have like a panel, imagine a big like chunk of rock that blocks the light from that star, it's going to cut off all light, all colors simultaneously. Like red light isn't going to make it through, blue light isn't going to make it through, green light isn't going to make it through. It's going to just, it's a hard cut. But how can you have like a panel, a thing, a big chunk of rock that like lets in blue light for a little bit before cutting it off, but lets red light through right away? What can do that is dust, is little grains, little molecules that will react differently to different frequencies of light. So what we think is this is just an unusually dense dust cloud, like a debris cloud close to the star that's orbiting around it. And every once in a while you get almost like a shadow, like a big chunk of dust, of junk, that blocks the light, and the dust is able to block different kinds of light in different ways, and different efficiencies, different quicknesses. It's dust. And yet here we are, I forget how long ago it was. I think it was about 2 years ago. 2 years later, people are still asking, and I have no issues, Matthew DeFleury, with you asking about Tabby's star, aka Boyajian star, but it kind of irks me because the most obvious answer from the beginning was it's dust. But that's not exciting, so it didn't capture the world's imagination. Here we are 2 years later. I still have to say, hey, by the way, it was dust all along. that's the way it goes. I guess it gives me something to talk about on the show. Now, we do have a caller question. I'm a little bit nervous about this because usually I screen, either I screen it or Greg screens the questions just to make sure, there's no curse words. If by the time this ends up on the radio, it will be cleaned up. But there is a live stream going on here, and so I'm a little bit nervous. So we're all going to go on an adventure here, us and the Space Cadets, and we're going to listen to Chris W. and his question. I've not heard this question ever in my life.
Paul, this is Chris from Atlanta, and I'm a huge fan of the show. There was something you said in a recent episode about the Event Horizon Telescope image that I wanted to ask you a follow-up question about. You mentioned that gas, as it gets closer to the event horizon, is less luminous and less visible to us. Why is that the case? Is it because of proximity to the event horizon that bends or scatters the light away from us? Or is there something else going on that has to do with the twisting or disturbance of space-time? In other words, why don't we see the accretion disk right up to the event horizon? Inquiring minds want to know.
Very good question, Chris. And thank you, A, for not swearing. And I think I heard a crying baby in the background. You might want to go take care of that. But I appreciate your dedication to science knowledge. Yes, this is super cool. This Event Horizon Telescope image that I talked about in the last episode. Very cool image, very striking image, very haunting image if you think about it too deeply. And what you're seeing is a specific frequency of light being emitted by the gas near the black hole. So it's not visible light, it's not radio light. This was ultraviolet emission. And this is a very specific frequency of light. So the gas that's orbiting and falling into the black hole has to have just the right energies to glow in this spectrum, in this part of the spectrum, in this kind of light. And it just happened to be strongest where the accretion disk is thickest and it's most energetic and it's most frothy. That is where it's emitting. And then as the material in the disk actually approaches the black hole, as it spirals in and in and in, it does tend to thin out. It like tapers out. It gets thinner and thinner and thinner before it finally falls through the event horizon. And so there's just less stuff to emit. And you can imagine this picture was so insanely hard to take in the first place that if you don't have a lot of stuff, even if it's really energetic, there's just not enough light being given off for us to really see it. And so hence you get that lovely shadow feature. Thank you again for that great question, Chris. We're going to take a quick break, folks. Don't forget, you can leave a voicemail anytime by going to spaceradioshow.com. You can also follow along with the Space Cadets on the live stream. That is spaceradioshow.com. How handy is that? It's the exact same link. I'm Paul Sutter. This is Space Radio. This show is brought to you by you. I can't emphasize this strongly enough. You really keep this show going. Go to patreon.com/PMSutter, SUTTER, to learn how you can support the show for as little as $1 a month, but preferably more. But hey, I'm not going to hold it against you. I'll see you after the break. All right. All right. Seeing some love between Astro B and Nightbot. Good for you guys. Glad a match could be made. And we've got plenty of questions. The Halo drive. I don't even know what a Halo drive is. Oh, methane on Mars. We could talk about Martian atmosphere, Richard Coons and pure ostension. Light pressure and expansion. How did we calculate the... Oh, he's got some good questions. Why are there no green stars? I like that. Okay, I think I got enough time. Or enough questions. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got way more listener questions ready to go. But remember, you can join the conversation by leaving a voicemail. Go to spaceradioshow.com, or you can just join the Space Cadets in the live stream every Thursday at 4 p.m. Eastern. Again, spaceradioshow.com for the links. That is fantastic. One website has all your answers. Now, I'm going to do a rundown. We've got lots of questions and not a lot of time. Starting again with Matthew DeFleury on YouTube asking, do you think Europa or Enceladus are hosting aquatic life? So there are these moons in the outer solar system that are locked in ice but have huge liquid water oceans, like globe-spanning liquid water oceans underneath those layers of ice. Could there be life on it? Could there be space whales swimming through them? Honestly, we don't know. Seems maybe unlikely. There might be microbial life. There might be single-celled. We honestly don't know. We know there's liquid water. And we think there are the necessary elements for life. You know, there's carbon, there's some methane, there's some good stuff going on. But we don't know if it had that special sauce that got life going. This is something we're absolutely interested in. Both NASA and the European Space Agency have missions designed to fly by these outer moons, take some samples, see what's going on, maybe, play like a space whale song and see if anyone answers. Another question, Nitbot on YouTube asking, when will the stars have consumed all the hydrogen in the universe? What happens when the universe runs out of hydrogen? So yeah, if you take a whole bunch of hydrogen, cram it into a tiny ball, you get a star, you get nuclear fusion. Most of the hydrogen in the universe is not inside of stars and will never be inside of stars. Most of the hydrogen is just floating around, too thin, too spread out, not caring about anybody and nobody caring about it. Only rarely do you get these special cases where hydrogen clumps together tightly enough in order to ignite nuclear fusion, and we call these places stars. Now, star formation in our universe is already on the way down. That's right, the lights are already getting shut off. How sad is that? It started being shut off about 9 billion years ago and continues through the present day. Little bit hard to predict when the last star will be born, somewhere between 50 or 100 trillion years from now. And 10 or 20 trillion years after that, the last star will go out. And that's it. And that's sad. But hey, sometimes life is sad. Moving on. Don't Gym on YouTube. Will we see more direct imaging of exoplanets soon? Yeah, by the way, folks, did you know that we take pictures of planets outside the solar system? When they're big enough and when they're hot enough, we can capture an infrared picture. And it just happens. We just do it on the regular. And there are a few observatories dedicated to exoplanet in direct imaging. As you can imagine, it's kind of challenging, but every few months we get a new picture, so you won't have to wait long. Bob on YouTube asking, why are there no green stars? So check this out. The color of a star depends on its temperature. Right? If you have a hotter star, it's going to be blue. It's going to be even ultraviolet. It has so much energy, it's going to give off that high energy radiation. If you have a cooler star, it's going to be down in the reds or even the infrared. Some stars may even only emit in the infrared. So we call these brown dwarfs. Now, what's in between red and blue is green. But if you're a star, and you're emitting right there in that sweet spot, right in the middle of the visible spectrum, where you have your peak emission is green, well, you're going to get all the colors, right? Because you don't just emit one color when you're a hot thing. You peak at a certain color, but you also emit all the colors next to it. So if you're blue, you're also emitting a little bit of ultraviolet. You're also emitting a little bit of less than blue. And if you're red, you're also emitting a little bit of infrared and a little bit more than red. If you're green, you're emitting reds and blues together. You're basically emitting all the colors in the visible spectrum, and all the colors mixed together in the visible spectrum equals white. Our star is, the sun is actually a white star, or it's a green star. It actually peaks in the green. And if you wonder why plants are green, just tossing that out there for some homework exercises. Campbell Duncan over on Twitch is asking, how did we calculate the elements made during the Big Bang? So check this out. We actually know, this is a crazy thing to know, that within the first 15 to 20 minutes of the existence of our universe, all the hydrogen and helium and a little bit of lithium was made. Like, there it is. That's our entire supply of hydrogen. We call this event Big Bang nucleosynthesis because that sounds really awesome. And how do we know this? Like, how do we actually do it? We know it because we understand nuclear physics. We know how nuclear reactors work. We know how nuclear bombs work. When our universe was 15 or 20 minutes old, it looked like the inside of a nuclear reactor. It had the right temperatures and pressures and densities. It looked like that. And we know the math of that. We know nuclear physics pretty dang well. And so we're able, this is back in the 50s and 60s when we first started attempting this, we're able to take those equations, the math we use to understand nuclear bombs and nuclear reactors, apply it to the conditions of the early universe, and actually predict the amount of hydrogen, the amount of helium. And from there, we were able to solidify our understanding of the Big Bang, because that was a solid bona fide prediction. Like, here's how much hydrogen, here's how much lithium, how much helium there is in the universe. So there you go. That's how we know, through the power of math and also experimental verification. And, I know I made that glib comment a little bit ago about why plants are green. Obviously, chlorophyll reflects green. I don't know why I even said that. So thank you so much to SAHM. And someone else pointed out, oh yeah, Journeyman Engineer, for pointing out that obvious blip. Yes, plants aren't absorbing the green light. They're reflecting the green light. Why they're green, you're going to have a biologist. This is why I don't do a show on biology, because I'll just get it all wrong. Richard Kunz on YouTube is asking, what's the deal with methane on Mars? So Martian atmosphere, super thin, don't breathe it, don't recommend it. There's a tiny bit of methane in the atmosphere. Okay, whatever. The methane seems to vary seasonally. In some months, I think it's summer months, there's more methane. In winter months, there's less methane. On Earth, we have a lot of methane in our atmosphere because of, basically cow farts. Really, biological processes lead to a lot of methane in the atmosphere. Now, there are chemical ways of getting methane in the atmosphere. So it's not like, oh, methane on Mars has to be life. It's not that clear cut. But this seasonal variability seems strange. Maybe one scenario is there could be microbes that are more active in the summer, and then they release more methane, and then less active in the winter and they release less methane. Or it could be some chemical process. We honestly don't know yet. Unfortunately, we're almost out of time today on Space Radio. But before we go, it's time for the Blue Shift. So many great questions. I love doing question shows where it's just all questions all the time. Give me a couple good ones for the Blue Shift. And I just realized that the live stream is missing the comments. I'm really sorry about that. So you just get a blank square next to me. What do we got today? Thank you again, Nancy, for collecting these. Ooh, M. Choupon on Twitch. Definitely going to answer that. Oh, and why, Bamba, why is the speed of light the speed of light? Done. All right, I got 2 questions. Yes, and by the way, I'll do it in the show. No, it will be too late. So Siren Modern Dance, they are doing a Kickstarter to fund the production of TikTok. This is our science and art collaboration. Go to, I'm sure Nancy will put up the link to the Kickstarter campaign. Actually, I'll put up the link. Today is the last day for the campaign. So this is, I mean, if you like science and you like art, and you should because you're a human being, then you should go support this project. Is the last day, just a few hours to go. It's the nature of time. It's an exploration of time through both the lens of science and art and movement. And it's just beautiful. It is one of my most favorite projects, if not the most favorite project I've ever worked on. Yes, I am in it, not as a dancer. No one wants to pay money to see that. But I am in it as a narrator, backed by dancers. Such a cool project. Kate St. Amand, wonderful choreographer, collaborating on that project. All right, I'm ready for the blue shift, and I'm ready for more questions. Timer. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, and I'm doing more questions in this very, very special episode of Space Radio. Bob on YouTube coming back asking, why is the speed of light the speed of light? Why isn't it faster? Why isn't it slower? Yeah, we don't know. The speed of light actually depends on two other things. One is called the permittivity of free space, and the other is called the permeability of free space. This is basically like how easily electric and magnetic fields can propagate through space, how easily they can move, how easily they can swim through space. And you put these constants together and you get the speed of light, because light is waves of electricity and magnetism. Why is that number and not another number? We don't know. There are a set of fundamental constants in our universe that we simply don't understand their origins. It's hoped that like an ultimate super theory of physics would be able to give us that number and why these numbers exist, but until then, they're just numbers brought about by observations, and that's all we got. Another question, last question I'm doing today. Oh, so many questions, so little time. M. Chupon on Twitch asking, is it believed that all orbiting masses create gravitational waves? If so, could we use a ridiculously sensitive detector to see beyond the cosmic microwave background? Yes, you walking around right now, you are generating gravitational waves. You are creating ripples in space-time. But the thing is, gravity is the weakest force, and not just by a little bit, by a lot of bit. Like, it is almost embarrassingly weak. Seriously, gravity, like do some crunches or some push-ups or something. Like, just focus, like get a little bit stronger. Everything generates gravitational waves, including all the craziness happening in the early universe. Those gravitational waves generated 13.8 billion years ago are still sloshing around today. They're just super weak. We are designing instruments in specialized gravitational wave observatories to try to detect these very early gravitational waves generated in the Big Bang. You have to put them in space because you need very, very long these are very long wavelengths, so you need the instruments very, very far apart. Kind of challenging. By kind of challenging, I mean insanely challenging, but not impossible. We are working on it. We are going to get that picture of the very early universe one of these days. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by Wonderful You. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Michalko for being awesome, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. You can call 888-581-0708 to join me on the air, and you can also join the Space Cadets live on YouTube, on Twitch. That's spaceradioshow.com for all the info, show notes, everything, and also how you can contribute. Thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Thank you again, Space Guys. Sorry the chat didn't show up over there on the live stream. I started it too soon. I just had to go, and now I have to go. Thank you so much, and I'll see you guys next week. I hope.